Good afternoon, and thank you for joining us for our live webinar, What is PLM and Why It's Important? My name is Elizabeth Steiner, and I will be the moderator for this webinar. Today, you'll be hearing from our president and founder, Steve Dam. But first, let's go over some quick housekeeping. During the presentation, feel free to send us questions using the panel on the right. We will get those questions answered in the question and answer part of the webinar. You can also interact with us on LinkedIn through the Innoslate user group or through Twitter using the handle @Innoslate. The webinar is being recorded and we will make it available to you after the live presentation, so please be sure to keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Dr. Steve Dam. He'll be discussing the distinct disciplines of PLM, how model-based systems engineering can help, and why PLM is important to the systems engineering community. Dr. Dam has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. He's also received an Expert Systems Engineering Professional certification from NCOSE. He continues to apply systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send Dr. Dam any questions through the LinkedIn user group, and then we'll go ahead and we'll get started.
Okay, thank you, Elizabeth. Appreciate it. And, as Elizabeth mentioned, we're going to do a quick what is PLM. It turns out that there's lots of definitions of PLM, so we'll talk about what we think PLM means, and then talk about how model-based systems engineering can help you meet your goals of PLM, and then also how you can improve your PLM practices. So first of all, what is product lifecycle management? So defining PLM, basically it looks like most people have it as 5 different distinct disciplines. It combines systems engineering with program management, which I include portfolio management is part of that, or the other way around, either way is to look at it. Product design, so this is where you get into your CAD drawings and things like that. That's always been a key feature of PLM. And of course, process management, particularly for manufacturing, but also just in general how your processes work and things like that. And of course, product data management, all your data. And we have massive amount of data on a product these days, and so capturing that, understanding it, manipulating it, working with it is quite a challenge. So many practices focus on 1 or 2 of these disciplines in depth, but I think to be successful you have to at least do all 5 of these, if not more, areas that people look at. Certainly the ILIDs I subsume into systems engineering and program management anyway, so things like reliability, availability, maintainability, those things I see as part of systems engineering. I don't really see those as separate disciplines. Anyway, so you need to do that throughout your life cycle. Now, when we look at life cycles, well, we're looking at the discipline a little more in depth. We actually did a little further analysis and tried to create a little mind map here, essentially. This is what we call a spider diagram in Innoslate. We captured information about each of these different areas, and we added a few things like handling complexity, being able to deal with the complex nature of all the information being pulled together. So some ideas like that. You see program management, it's not just risk, but it's risk, issues, and opportunities these days. People are looking at all 3 factors, and they're all interrelated to each other. Some of the other things that are on here, obviously your product data is a key part of it, your time to market, product costs, so many things that bring it together. But one of the most important things is your database be scalable. If you're really going to try to capture a large amount of information, scalability is very critical. So you want to make sure you have, for a true product lifecycle, you're going to be capturing maybe millions of pieces of information. And so to do that, you really need a very robust data management system. So I think the complete PLM capability really needs all these features, if not more. And it must produce the deliverables in all these areas. So that's one of the key things, of course, you're trying to do is you want to produce the products as output to be able to give to people particularly suppliers or management, to be able to see what's going on and how you're actually meeting their goals. And of course, to better understand the requirements, we really also need to better understand the processes themselves. So if we look at the product life cycle, there's many ways to visualize it, but really fundamentally they all have sort of the same phases and steps roughly, maybe in a little different orders and a little different emphasis. But fundamentally, one of my favorites is to look at it as the V diagram. And the reason I like that so much is if you start at the beginning, you realize that you're in a current state of operations and maintenance of whatever you're doing. There's almost nothing that's a complete green field where we're starting from zero. So there's a lot of work in the process management area there. In fact, if you're doing a good job of your business process reengineering and analysis, you're constantly looking to see how can I improve my processes. So process modeling, process management is a key part of that. As you come down the V, you start finding problems in the current state. You're trying to say, well, I really want to be able to improve that, and so I'm going to go off and try to come up with the requirements fundamentally for going off and finding a solution to my problem. And of course, ultimately that gets decomposed into something I could go off and buy or build. So the product design phase is at the bottom of the V here. As you go back up the V, you need to make sure you do your integration testing and your operational testing and ultimately transition to that future state where, again, you're still looking at process management. And how does it affect the processes, this new capability? Is it going to change my processes? Probably, and so I need to be prepared for that too as I'm working through this. Well, clearly, at least to me as a system engineer and program manager, I'm doing systems engineering, program management, data management all throughout this life cycle. So it's really end to end. It's not just that beginning phase or ending phase. So we need to capture information in each phase and step to understand and document the design and development of the product. This is how we know that we have what we wanted to have and that it's meeting the actual need that was expressed in the beginning, or at least the evolved need, as we all understand that requirements change over time because, frankly, everything's changing over time. The longer this life cycle is, the more change you should expect. That's the reality of today's product world. And of course, in most of the commercial area, that product life cycle timelines can be a matter of months, if not weeks, on many cycles. So in the government world, we're used to years, decades in some cases, unfortunately, for the cycle. So, but again, that's because the systems are so complex and so intertwined, and the issues of all the funding and things like that go on. So really that systems engineering and program management really is meant to cut across the life cycle. So we designed a tool for that, and we'll talk about that a little bit later. So if you noticed when you're coming down the V, you saw a diagram, and it looks something like this, a little icon of a diagram. This is a very classic diagram. It was originally designed out of MIL Standard 499B. But it's one that I've used over the years and feel very comfortable with. It lets me work top down or bottom up, depending on where I'm working from. Or often I'm starting with very high level requirements on many tasks where I don't have a clear-cut anything but an objective, a high level objective. So I'll use the functional analysis to do that process modeling, understanding the business processes early on in the stage to understand where are the problems and use that to help generate what are the requirements I should be working towards. So it has a key function. A lot of people, when they're thinking about requirements management, are only thinking about an external group of people handing you a set of requirements. If they've done a good job of coming up with those requirements, they probably did functional analysis to actually do it. But also sometimes you're looking at the current system and you just want to understand how it works today and why does it work the way it does, because things changed over time, it wasn't well documented. So that bottom up is also another way you can use this. So again, it's classic. Again, it's designed for creating specifications, so you can go off and buy or build something, bills of materials, work breakdown structures, all the kinds of products you'd expect in a lifecycle management. Coming back up the V, we have another process we look at, which is similar to the other one in that you have integration, the verification, validation, planning, of course, is a major piece of that, and a thing we call design monitoring. Design monitoring is there to make sure that you remind yourself that all through this life cycle, the role of the system engineer particularly is to monitor the design and make sure that there are changes, that the changes are documented and controlled properly as needed. So the key here is to work through that all through these processes. And of course, recognize that customer satisfaction and transition to the operation is a key part of these steps. So that's kind of a thumbnail on what PLM is to me, and at least how we see it here at Spec Innovations. So how can model-based systems engineering help? And of course, model-based systems engineering, if you're not familiar with, has become a little bit of a buzzword. It's used a lot, and a lot of people don't fully understand what it means. So I'm going to try to define what I mean by it here. So here's the definition from the International Council on Systems Engineering in COSI. They say it's model-based systems engineering is the formalized application. That's my emphasis there, of the formalized application of modeling to support systems requirements design. And you read it, of course, that's the whole life cycle is what they're talking about. So basically it's pretty simple. It's really, I'm going to model, and I'm going to model everything across the life cycle. Great. But what does this formalized application mean? Or is it just a buzzword? Is it just another set of words that we're adding to the whole process? So what does it mean in practical terms? Well, the disciplines, again, are not limited, or include but not limited to requirements analysis and management, functional analysis and allocation. The physical architecture modeling, that's a synthesis step in that previous diagram I showed you. That's everything from block diagrams to detailed CAD designs. And of course, verification validation, which includes simulation to be able to understand how well things work, and ultimately, oftentimes we can't actually put something in an operational environment and test it in the operational environment without causing problems in the current operational environment. So we simulate, we work through that long time, many times before we actually do the implementation. So again, in other words, it's really all the aspects of systems engineering and program management. And one of the things I learned over the years is that if people try to split those two out a little bit, but if you look at them, both are trying to optimize cost, schedule, and performance. Just the system engineer does it for the system, and the program manager does it for the program. So really, it's fundamentally the same kinds of things you're doing, and you can apply the same kinds of techniques and analysis that actually help you in both domains. So model-based systems engineering the main difference is really that use of the modern systems software tools to capture the data in a repository and convert the data into information through analysis and visualization. And ideally, what the model-based part of this does is make it so much easier to reuse information and capture the information at the data level, and then create the information knowledge that's needed from that. So one of the problems is the word model, and models can come in a kind of a spectrum. Anything from a paper-based approach where you really have nothing formal to where you have maybe a template flowchart kind of thing that you use, or drawing-based model standards like IDEF is. Moving on up to formal ontologies where the data drives the information being captured and the visualization of that information, all the way up to really what we call computable modeling standards, where you can go and interrogate them automatically and understand that there's doing what it's supposed to be doing. So it's sort of like being able to test the model, being able to make sure the model makes sense, is logical, rational, and works. So really, we've got to get ourselves out of this paper-based approach. We still are kind of automating paper-based approach. We're kind of just doing drawings, but we're using electronic tools to do the drawings, and that has some benefit in reuse and things like that, but you're not capturing all the data, and the data isn't interactive as you are in the computable modeling standard. So the benefits of models, of course, is to provide traceability in many dimensions. Okay, so there's many pieces of information that we're looking at and trying to understand, and we want to be able to trace things between them. It's not just requirements to the product, it's requirements to what was the capabilities you were looking for. Does it really meet those capabilities? Taking those and turning them into, well, what's the inputs and outputs that you have to deal with? What are the risks? How are those associated? What decisions were made? Lots of information that you want to capture and understand. Some of it programmatic, some of it technical. And of course, the models need to be automatically validated using simulation rule checkers. So again, every diagram in language has some kind of rules set to it. My favorite was the IDEF 0. It's a 100-page document to explain one diagram out of the IDEF standard. It's obviously a lot of rules as you're drawing that. Most of these things are too hard to do manually and make sure you're consistent. Having the tools do that for you really helps a lot. Of course, models can be interrogated. You can go and try different things. You can look at them in different ways. You can explore different, you can do what-if analyses. If I change this, what's the impact? So you can do impact analysis and very quickly find where you might have problems. Of course, models can be reused. I can create a model that I for one product that then if I'm creating another similar product, I can just start from that model and change it and adjust it to match the new product line I want to create. And of course, models can easily be changed. So clearly, PLM relies on models to be effective. So model-based systems engineering provides a means for developing and managing those models. So it seems like it's a pretty natural fit to have the two come together. So how can you improve your PLM practices? So first of all, we need to do a better job of systems engineering. You want to use a complete systems engineering environment, something that gives you requirements views, functional and physical diagrams, discrete event, Monte Carlo simulation, test center, all those kind of features tied together. If you are trying to use those with different tools, moving the data back and forth is time consuming and expensive and hard, actually, and error prone. It's easy to somehow not have the right mapping between two different ontologies, in two different tools. And some of the tool sets weren't designed to work together, so they aren't as seamless as they might appear to be on the surface, so you have to watch for that. Of course, capture your related program management information, so you want to model your management processes, you want to be able to create work breakdown structures, capture decisions, identify and manage risks, and of course, Gantt charts, and cost. Be able to do the cost tracking and control that you want to work with. Of course, having some kind of interoperability with Microsoft Project is probably going to be essential for you, because if it's not, that is sort of the lowest common denominator at the moment in the industry, so a lot of people have it and use it. Of course, capturing product design, you want to be able to capitalize and visualize your CAD diagrams. You need to be able to make sure those become objects in your database as well, though, so you can relate them together. And then, of course, be able to capture artifacts from other and more detailed analyses. So, for example, if you're doing a computational fluid dynamics on the aircraft, then you want to take the results of that and capture that and make sure you can control and deal with that and be able to find that information quickly and easily. And of course, developing the design specifications from the models automatically would be really nice. You'd like to have that ability as well. And of course, capturing your test plans and results. Of course, also you want to manage better manufacturing processes. Of course, again, here's where your process modeling and your simulations come into play. You can model states and modes. You want to be able to conduct failure modes, effects, criticality analyses as well with this. You want to be able to interface into MPM tools. The manufacturing tools are all kind of independent of each other and then may have interfaces, so a lot of modern tools can be interfaced using a software development kit or APIs of your design tool. And of course, integrate with other high-fidelity tools as needed. And of course, improve your project data management as well. So again, if you need attributes like part numbers and descriptions and vendor supplier information, material data sheets, on and on, you want to have some ability to capture that data and model it and be able to edit a schema. So if your tool comes with a schema, then you want to make sure you can edit that schema and meet your special needs easily. And of course, manage electronic files using the artifacts. So some kind of way to capture those electronic files and work with them. And these are, I'm showing you diagrams from our tool that do that, of course, as we've been going through this, so you can get an idea of some of the things you can do. Of course, constructing work breakdown structures and builds of materials as well. So another thing, again, I think is really critical is real-time collaboration. You're not doing this by yourself, so you need to collaborate with your team members across multiple views. You need to show real-time status update, and you need some kind of group chat. Here's an example where it's showing different people actually accessing the same object, maybe in different views, and on the sidebar is the chat between the people, so they're talking to each other to say, you know, what are you working on, how are you doing this, and they could be anywhere in the world doing this if you're on a web-based system, a cloud-based system. And of course, project notifications as well, having some way to know when things have changed in it, so ideally automatically it'll notify you when something's been updated. And of course, scaling to meet the need. You need to be able to test to millions of objects and a large number of simultaneous users. These are just some test results. So for our tool, we're looking at 10 million objects in a database is sort of the maximum we've tested to so far, and about 1,000 simultaneous users. So again, you want to be responsive even with the large databases, because if you're not, it's not a very useful tool, and you want to be limited only by the hardware you run it on as much as possible. Because with cloud computing today, you have theoretically access to almost infinite amount of computer power. You also want to be easy to use, have some kind of overlays, rollover definitions, for example, so there's kind of built-in help kind of capability. It's just showing you an example of the what's the definition of complete is over here on the right. It pops up as you hover over it to say that complete represents if this requirement expresses a whole idea. Drag and drop capabilities, of course, all kinds of simple, easy to enter, like from a sidebar, attributes and other information, responsive, and of course all developed to the latest web software standards. So as you might imagine, I described Innoslate, so why don't I give you a little live demonstration of the tool. And here it is coming up, and the first thing you see is the dashboard. And I'm just as one of my many examples that I have here. And you notice even today I was playing with it, so you can see the notifications panel here on the left. And if I'm the owner of the file, and if I've subscribed then to everything automatically, so if somebody else changes this, I know I get an email, and I track those changes and see what's going on. Up at the top here, we have a Getting Started panel. If you're unfamiliar with the tool, highly recommend you read the online guides and tutorials. You can watch the tutorials for those of you who don't like to read, which is a lot of us. And of course, the model maturity checker is here. This is actually an early version of what we have now called intelligence. These can be moved around. You can dismiss panels if you don't want to see things, and adjust them. Statistics is a way to quickly see how many things you have in each different class of information, and then the outer ring shows you labels. So this is how many, I have 28 derived requirements is what this is telling me. So that's an important thing to know. And then other information about the ontology is here. Total number of users, all that kind of thing as well. And of course, sharing your feedback. So you can want to share your feedback information. So again, this has some of those features we were just discussing. Another thing, maybe next thing you'd be doing, first thing you'd really be doing if you're just starting a new one, is you come over to our import analyzer and you bring the information in. You can read in a Word document. Of course, our own import-export capability. Excel is a very nice CSV reader. Again, read the notes down at the bottom here. They'll tell you how to do this, and there are examples in the help package. We even have a specific one for doors. If you're trying to migrate from doors, I highly recommend doing that. And then, of course, if it's just plain text, a PDF file. By the way, there's a trick with PDF these days. If you have the new Adobe Acrobat Reader, you can save your file as a Word doc, and that gives you a very nice importable document directly into our Word thing. Otherwise, what we're looking to do here, in case you're not familiar with this, but what we do is we assume when there's a numbering scheme that's hierarchical, that these are expressing parent and child relationships. And so we automatically create the relationships for the parents and children with it, and let you work with that. You have the ability to, once you configure it, you go through the copy and paste layer, and then a preview. In every case, you have the ability to preview the information before you bring in the tool. So that's just a very quick thumbnail of that feature. Once you get something into the tool, you might go to you create a requirements document, bring that in. We give you a number of different fields to work with our requirement. This is the requirements view. You can have as many as you want. We have many different ones. You can baseline them. Baselining function is it's up above here. To baseline, you just click baseline and add that baseline as you need to. This is a very quick and easy way to do that. This is what we call a requirement, and we have both statements and requirements. A statement is just a contextual piece of information that helps you, maybe like even just a header in a document you want to capture and give you structure. Here's a specific requirement. It's written like a requirement. It has a rationale field. You can add labels to it. So if you say this is really a performance requirement, I can add that label to it here. And then it'll add the label over on the right. So you'll see that performance requirement label popping up. Another aspect of this is if you want to see the other attributes, we have many quality attributes we've associated with it. And you can even add your own checks, or you can hide these as you want to. So you don't have to do all of them, but again, they're there intentionally to help you. If you've got an example here, like the next one, where it looks like it had some problems, that's because we used our quality checker. And the quality checker goes through and reads the actual description field and uses that information to determine how good a requirement is it. Is it clear, complete, consistent, correct? Does it imply a design? Is it feasible, traceable, verifiable? Now, we check most of these now. The only two we don't check are correct and feasible. And when you see the definition, you'll see why. One of them is it legal? We're obviously not going to go searching through all the law books in the United States or the world to do anything with that. So it wouldn't be much good to have it in there. Again, you can add into any of these description fields, you can add pictures, you can add hyperlinks, pictures or images, diagrams, tables. So again, this can be very fully functional. So you can actually author your requirements document right here, and we highly recommend doing that as well. We have other document views that are available to you too to author other documents that are critical to your product lifecycle management. I happen to have gone to the requirements tab. That's usually one of the ones we default up as pinned, but the other documents views are ConOps, test plans, ISLP, LPs, SOPs. These all have templates, suggested templates from usually government sources that we're using, and of course you can add your own and create it whatever you want for your own template. So that's part of the document management or data management as well, is that capability. As we go through, and you notice here it has a trace to, so this has been traced to something, so I can click on it and I can go find what that is. I can in many different ways, but let's go open the entity view for it. This is the entity level view of that particular element, and there are lots of relationships. Everything's related to everything else, so you see that. So it's sourced by the artifact, so that's connected to this particular requirements document. It was traced to RM, so this is another document actually, another place where we created requirements. So if I wanted to go to that entity and see what it was, I'd just click on it and it would take me right to it. So it's an action. So I created this action, and that's part of a model I've created that I then am using across the tool. So I can go walk up that model by just clicking on the parents and see the model a little bit later. So we're going to do that in a second here. So again, these are ways to navigate very quickly and easily the information and migrate the data and work with the data. Let's go back to requirements view. So another feature we mentioned is the whole being able to do the system engineering modeling and simulation. So there's a diagrams view as well, and there's 27 different diagrams in the tool. We use what primarily is what's called lifecycle modeling language. That's the one where it is the very much simplified ontology and set of diagrams. So here's some of those things that are in it, the action diagram, things like that. If you're more used to the systems modeling language, those diagrams are all here and available to you as well. So you can do all your modeling you want to do in the language you would like to work in. And for us old timers, there's all kinds of other things like there's of course class diagrams for UML, but there's hierarchy charts and I-square charts, ICOMs, IDEF zeros. There's a really neat thing we've got called the layer diagram. Let me show you that very briefly. This is how you would draw that kind of hierarchy often in PowerPoint, but these are actually a decomposition. So if you look at it, it's showing you the connection between the spacecraft bus and the payload. And then in the payload, it's decomposed by the telescope and the avionics, payload avionics, and these other elements. And so you can see them all together in one place. So this is actually a very neat way to see your information, very compact way, typical of the type of thing you draw in PowerPoint, but these are all elements within the database. So as you click on them, the information shows up on the sidebar about them. You can work with those attributes. Diagrams view for a minute. So lots of different things to work with. Again, here's the All tab as well. So one of the things you often want to do is as I mentioned, is the functional analysis part of systems engineering. And so here's an example or process modeling. This is the same thing. It's the process analysis. So this is a process model of what's called a design reference mission for the satellite system. And it's including the launching and deploying the satellite, getting it into orbit and getting it operational, and then an operational loop where it goes over time and operates, and in that point sometimes there might be a problem where you have to move the satellite or do something contingency, maybe shielding from radiation or something. There's all kinds of things you might want to do to put it in a safe mode. And so that's the contingency operations, and we didn't even decompose that one, but it's available. for that further analysis if we wanted to. The decompose button here lets you click down to the child diagram, and so you can see it in this and its depth, and it keeps being decomposable down below. So if I want to go back up, I just come back up here to the parent diagram. So one of the things that we mentioned is it's not enough just to have a diagram and a model I can work with. I want to be able to simulate it. And so there's two options in the tool, discrete event and Monte Carlo. And this is the discrete event, and it shows you a 3D model of the actual the diagrams. So you see the different levels. And as we hit play, this will be showing it walking through. You see it step by step walking through the diagram. It's building the timeline below in a Gantt chart kind of format. You can see it's adding up the costs. The launch was the big costs, a lot of the costs there initially. They'll build that over time. Resources are being adjusted over here on the right. See the different things. We have just a couple of resources in here. We have a forest fire, which is what the satellite's supposed to detect, and then water which is showing you some of the putting out the fire, and that whole part of the operation. You can speed this up if it's going too slow for you. You can speed it up, go as fast as you want, or you could step through it. You have both options, of course, with a discrete event simulator. Let's really speed it up. So once you finish, you're left with this information. You can work with it. You can analyze it. There are all kinds of reports available with it as well. Detailed resource reports, things like that. So all kinds of things that can go out and be worked with. If I go back, I can also test it in the Monte Carlo mode as well. Just do that very quickly. It doesn't take too long. So it's running through, well, there's 1,000 iterations. So we can put that in the background maybe. I'll create a new tab here. We'll see the results when it's done. So you notice what I'm doing, I'm creating a new tab with this in the same database, and so you can have multiple windows and be working together. You see different things, some other facets of it as well. Lets you work together. So another thing we mentioned was the testing side of it. Still kind of doing system engineering. So here's the test center. So this lets you capture your test results and work through them. You can see how they roll up as well. These are linked back. Again, here's an example of using a diagram in the tool. This is actually that same reference mission, except for we removed disposal, because disposal obviously is not something you're going to test necessarily directly with your first launches. So that may be something you do later in the process, or you do virtually through simulation. So these are things that would let you see and work and create the rest of the test criteria, your expected results, your actual results, and capture that. Again, any one of these you can click on and open that entity view, see more information about it. And of course, there's also information about the timelines, and there are many reports available as well. So go back. Let's see if our Monte Carlo is finished yet. It's still working in the background here. And of course, lots of different reports. So anytime there's a report button in almost any view at the top, that's the place to go get your reports that you need and things like that. Another thing I mentioned earlier was the whole idea of the work breakdown structure. So let's go to database view. And one of the entities is cost. This is our table view of it. We have actually 3 different views here. You can see it this way. This is a view to use. We sort it by number. This is a view you can use to just do bulk things, like if you wanted to delete a bunch of things at once, or add a bunch of all the same label to a lot of things at once. This is a good view for that. We have a tile view for pictures. So if you have pictures and picture-oriented, you can use that. And of course, our spreadsheet kind of view, which is nice. This gives you an idea of looks a little bit like Excel. It has some of the same features as Excel in that you can I could drag down and duplicate information that way. So I actually am creating new entities when I do that as well. So this is actually a very powerful view to work with and edit your information very quickly and easily. So if I go and get the work breakdown structure, which is this entity here, best way to see that is as a hierarchy chart. And this gives you your work breakdown structure. Again, you can decompose this to whatever level you want. It's going to be very detailed. I think I did one for a major government customer. It was about 1,000 elements in the WBS, and so you can capture any structure you want like that. So that's a kind of product you can add to it. And a lot of places where I would add those kind of things is to different types of reports and things. So project plans, test plans. So here's an example of a test plan. And it's the acceptance test plan, so we're capturing some risk information. This is a picture actually that was created, but I also linked it to the actual risk diagram. So if you notice, when I was in the middle of the diagram, in the middle of the document, I clicked on it, and here's the full-up diagram as well. So again, that's a hyperlink. It opened a new tab, so I can just click the other tab and I go right back to it. We do have figure captions as well that are part of this, so it's actually very interactive, and you work with this as you need to. See, here's your figure caption. You can have a floating title if you want as well. And here's that link that I made to the other part of the tool, which has the risk matrix in it. And you can build tables, use other diagrams as well. So it's again fully interactive and workable, and it makes you a very nice output for in a Word document. So the report for this, let's cancel that. You see reports, basic output as a document, as a docx document, so you can work with it as you need to. So this lets you build everything, working through the entire life cycle, building all your products that you need. It's all internal. You can even allow people to come in and read and comment on it. So if you give them read-only access, if you share as a read-only person, then that would then allow them to come in and add comments to what you're doing. So again, we've actually piloted this. One of our compatriots has actually done this with NASA and gone through their entire milestone review cycle using the tool to do just that kind of a model-based review. So I can go on, but I'd really like to leave some time to answer some of your questions and make sure that I hit the things that you care about. So Elizabeth, do we have any questions?
Hi, Steve. We have a few questions so far. If you haven't done so, please use the panel on the right to ask us questions. So the first question that we have is, do you have full SysML compliance?
Yeah, so that's an interesting statement. We have all the SysML diagrams. Do we have every little nuance and aspect of every SysML diagram? Probably not. We found that some of those were unnecessarily complicated. And many times all you're doing is things like different kinds of ports. Really the only difference is, to us, is a label. And so you could label the port to be the different things. It just doesn't show the symbol. We thought the symbols became too complicated for people. And we were having people zone out on us with them. So we dialed back the palette so it was a little bit more usable and understandable. for most people. So again, if you're a purist, absolute, got to have SysML exactly as it is out of the box, we're not doing all that. So, but again, you don't get some of these other features that you're looking for, really, that are really important. Next question.
Thanks. Thanks, Steve. Let us know if that answered your question. Our next question is, do you have version control?
Yes, all kinds of version control, actually. So if I go to the database again and get at any entity, I'll open the entity view. First of all, there's a history associated with every entity, and it tracks all the changes to anything about the item. If there's a relationship change, looks like we added relationships here. If we added a unit, it looks like I added the $ unit there just recently. So it gives you who did it, when they did it. You can revert back if you need to a previous version. So that's one level of it. Another level is, of course, as we mentioned, for an actual document, and this is true in requirements view and documents view both, is the baselining I showed a little bit earlier. So if you want to add a baseline, you just click the baseline tab and add the new version number baseline. We have a number of those already here. It would change all the orange bars to blue. Okay, and if you then make a change to it, so here's the current version of that same document, and it changes it to yellow. So again, yes, there. And last but definitely not least is branching and forking. What this allows you to do is create whole new branches of the project, and you can then make changes to those branches. You can then merge it back in. You can even, if you generate this, you can push it either way. Okay, so in other words, if I made a change to the master, I can change it I can push it to the branch, or I make a change in the branch, I can push it to the master. So again, fully functional configuration management of the entire database and model.
Thanks, Steve. Our next question is, how can I customize the system framework for each project?
The best way to do that is to come over to the schema editor and go through and decide whether you want everything or not. First thing is, let's say I'm not doing SysML, so I don't need equation. Then I could go ahead and just hide that, and I wouldn't see it. So if I save that change, and I go back to database view, equation's gone from my sidebar here, so I don't see it anymore. So things like that, it's that simple. You can simplify it, make it easier for people to focus on things. I recently did an issue tracker where all I wanted to do was see the issues and the assets, and so I hid everything but that for those two items to work with, and then made a very simple input deck for trying to do something very simple. But what's nice is then I could use that and push that to a parent branch, which had the bigger model in it. So again, that's a great way to interact with it and use different aspects of it to do that. Let me put that back because I'm going to forget otherwise. I won't have it next time I want to show the actual diagram. So
we actually have another follow-up question to that question. How can you add relationships?
Oh, easily. There are many different ways to do that. So let's take the easiest one first. So let's go and pick let's see here, open entity view. So the simplest way is to come over and add it right here. You just do an add. You can add existing or new things, and each relationship will tell you the things it can connect to. So you don't have to guess. And then we in the entity view have different tabs, which is controllable in that schema extender. So you can adjust it there. So this is the default ones we have for this particular class, which is, I think, an asset. Yes, it's an asset. And then so I try to group the program management kinds of things together here, and of course then all of them together over here on the right. So you can see all the different relationships. Again, this is all controllable by the schema extender. that's one way. Another way is to go to the spider diagram, and I can create relationships between things right here, and it'll tell me what relationship I can add, and if there's no relationship, it'll tell me. So that's also available. I can bring in new things, create new relationships. You can see maybe it's orbited by. So again, that's another quick way of doing it in the diagram itself. So now most of the diagrams do this for you automatically. If I went to a hierarchy diagram, it automatically creates the parent and child relationship. If I use the layer diagram, it's going to create also parent and child relationships. So each of the different diagrams use these relationships so that they can work together on it. For example, here's the requirements diagram, and you can see the different items that are connected to each other, and then you can follow those lines and ultimately see the relationships as well. So if I open up the entity view of that one, I'd see those relationships, the trace to from relationship and things like that, decomposed by, sourced by. So again, these are all, in many of the diagrams, they handle actually all that relationship for you. Next question.
So I think we misunderstood her question a little bit. She was actually asking about the schema editor and how you can add relationships through that.
Oh, I'm sorry. I'm sorry.
But that actually answered another question that we had, so I didn't want to stop you.
Okay, good. So here's where you add more relationships here in the schema editor. It's just an add relationship here. And if you don't have them, then you want to create new ones, go to the actual relationships piece and create the relationship first, and then go over to the class and add it as you need to. I know I'm going fast, but I can do it slower if you. But I think you can play with it and see, and it's very easy to work with and very easy to adjust. And just I highly recommend importing one of the sample projects and trying them out and playing with them and breaking them and have fun with it.
Thank you. That answered her question.
Oh, good.
Our next question is, how can you add relationships in bulk?
Okay. So again, in the entity view, just stuck with one of these things. Let's go here. So open entity view. So if I want to go ahead and add a bunch of relationships, I could just keep adding them here. So I can add new assets. I can add existing. I can go through and select a bunch of these. I'm not going to do this because this is what I want to do. This is a live model, but that's the way you do it. You just hit add, and it add them all in. Does that make sense?
Yes, thank you. We have 2 more questions. If you have not had time to answer a question yet, please go ahead and ask us a question while we still have some time. So our next question is, how does CAD work in Innoslate?
Okay, so we have a CAD viewer capability. Let me go back to database view. And what we do is we bring in an artifact, and I believe here's the one that has that. Yeah, let's go to the entity view of that. Okay, so if we want to just see it, first of all, you would upload the file. If you upload a .obj or a .stl file, it'll come in and it'll give you this View CAD button. So all you do there then is view the CAD, and you can adjust it and look at it in different ways. So if you want to create assets associated with it, you use the Create Assets button. That only works with the .obj. It doesn't work with .stl yet. So again, those are things we want to continue to work on, but again, it's the basic capabilities here. And then so it creates this reference SPI and has that list of the different entities that are associated with it.
We have one last question.
Sure.
Do you have any user guides?
Oh, yes. Lots and lots. Let's just open up another So if you go to the main website, go to the Help Center, and you can see all kinds of the how-to guides, things like that. If you click on any one of these, you also see the user's guide, so you can go through and work with that and see the different aspects of it. So it'll take you to whatever you're looking for, project dashboards and things like that. Again, highly recommend the new updated webinar web views. So webinars that are available. And of course, here's some of your sample projects you can download and work with and import into the tool, and they're all up to date and working with the current version. Anything else?
That's all the questions that we have time for today. If you still have any questions, please feel free to reach out to us after the webinar. If we did not get to any of your questions, we will contact you. We would like to thank you again for joining us today. As a reminder, we will be following up with you very soon to send you a link to the recording and the presentation slide deck. We would also like to invite you to our next webinar on DODAS 2.0, August 24th at 2:30 p.m. Eastern. So be sure to check your email for the invitation. We also encourage you to visit our website as well as connect with us on social media. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar on August 24th. Please enjoy the rest of your day.